On, let's see. Oh, not this. I'm guessing that the first few were pretty straightforward. I'm hoping, right? When we get the first 3 or 4 of them, Shimki, which one would you like to look at?
12.
12, absolutely.
Yeah.
And that's kind of what I was guessing. So here's what happens. I'll rewrite this. We have secant over cosine minus secant times cosine. Now, one of the things that we should recognize right away is that secant and cosines are reciprocal properties of one another.
Right.
What happens when you multiply a number to its reciprocal? 1. Very good. So I know for a fact that no matter what, secant times cosine is 1. Okay. Same deal over here. Secant divided by cosine. Well, I can do one of two different things here. Since I have a minus 1 right now, I'm just going to kind of see if I can deal with the secant. When you have a fraction, remember, you can rewrite it as secant over 1 times 1 over cosine. Are we okay with that? That's 1 over cosine. Secant. What's secant times secant? What's secant squared? Minus 1. Oh. There's other ways to do that. Some people have gone from this point here and gotten a common denominator. You get secant minus cosine all over cosine and worked out of that. It's a little bit messier, but you could do it. All right, yes, sir. I'm getting it. Oh, I thought you pushed it. Is that a little bit better, Shirky?
No.
No.
What's wrong, Shirky?
It's stupid, that's what's wrong.
Those are reciprocals.
First thing is extremely.
So let's make sure, before we do anything else, let's just make sure that we have all of our stuff written out with the reciprocals. Cosine is 1 over secant. Secant is 1 over cosine. Sine is 1 over cosecant. Cosecant is 1 over sine. Tangent is 1 over cotangent. Cotangent is 1 over tangent. Bless you. Tangent is sine over cosine. Cotangent is cosine over sine. Those are all the generic reciprocal properties that we've worked with. Okay, those are all the ones we've already dealt with. The newer ones are the Pythagorean identities. The Pythagorean identities were sine squared plus cosine squared equaled 1, which meant you could rewrite it 2 other ways. Sine squared is 1 minus cosine squared, or cosine squared is 1 minus sine squared. Okay. The other one was 1 plus tangent squared, and that equaled secant squared. Move the 1, you can get tangent by itself. Excuse me, tangent squared. And then the last one was the cotangent. 1 plus cotangent squared equaled cosecant squared. And I can do the exact same thing by moving the 1 over, and I can get cotangent squared by itself. And I would get cotangent squared is cosecant squared minus 1. Okay.
Are we testing
No.
Mr. Murphy.
You know all of those.
I wish.
This one is easy. You really only need to know 2 new ones. What's up?
Do you have another one of those little sheets?
It's in your book.
Yes.
Yep. 14.3. Or you can write this down real quick. Okay. Yeah, Bella.
Do those work if you take away the square?
What do you mean? Like sine plus cosine?
1 plus tangent equals.
No,
It
that
has
won't.
to be squared.
It has to be squared.
Okay.
Pythagorean identities have to be squared. That's why they're squared.
Okay.
Yes, sir.
What's that line between sin squared plus cosine?
Oh, I was saying that you know this one. You should know that one.
What did I say?
You say sin or sine.
Yes.
Okay.
Sine.
So that's INE, but that's okay.
I'm talking about cosine.
Sine.
Like sin.
16. 16 should be really quick. Yes, sir.
Actually, do 16 now, that's my question.
Well, 16 is an identity, so the answer is just secant squared.
Okay, but is there like an order of operations to this stuff? Or
Just like it would be normally.
So do I describe this?
What happens with the 50-degree stuff, as long as the theta value is the same for everything, it works. So if you look over at 18 where it says secant squared 350 minus tangent squared 350, the theta value is the same. So secant squared minus tangent squared is 1.
So do we just disregard it for all sake?
And like I was saying yesterday, you're not going to get ones with different values of theta. You can't. That's pre-calc. Well, then we do sum and difference formulas, and those are, that's when you take something like this. And then you have a certain formula to follow through on. But we do that later. 20. Oh yeah, JC, what do you got?
So the 50 just goes away, it's not secant squared 50.
You could, it technically should be secant squared 50, but it doesn't matter because I unfortunately had a very bad few years where I just kept forgetting to put theta, and I still seem to forget to put it there. You're not going to get a different theta value so that to make it show that it's not going to work. So it's not a big deal if you don't write it down. I'm going to continue to talk to you to see how long you can get somebody to keep their hand up in the air because it's kind of funny.
Okay.
How's your day going so far?
That's good. How's
Good.
yours?
Not bad. I'm getting a little hungry. I might have to have an apple here pretty soon.
What's the lunch?
I'm hungry too.
I'll buy you Jim
Lunch?
John's.
What do you want?
Crap. Oh, if it's like cosine squared minus 1, is that not the same as 1 minus cosine squared?
What's 4 minus 1? What's 1 minus 4?
Negative.
Are they the same?
So.
Next problem.
That's perfect.
What did you say, Martin? It's like a next problem.
What did she say? Are you talking crap?
No, it's the same problem.
That was awesome. All right, so on 20, you've got 1 minus cosine squared over sine times cosine. So as soon as I see things that are squared with ones and things like that, I've automatically going to look and see if I can find some Pythagorean identity that makes that work. Very good. Sine squared. 1 minus cosine squared is sine squared. Mr. Pope.
We're going to have the identities memorized.
Yes, sir. This now becomes the same problem as this. Simplify it. What do you get?
1 over y.
Huh?
Oh, that problem.
And what's sine over cosine? There you are. Let me get you tangent. Sir?
Okay. I'm asking another question, I'm sorry. But when we did the triangle stuff, when we do a tangent equals y inverse, right?
Yeah.
So why is it flipped now?
It's not flipped. What's your y value? When you're placed on theta, when you place theta at the origin, isn't that your opposite?
Oh, okay. I think I understand.
Your opposite's the vertical. Your vertical is your sine value.
Okay. Oh yeah, you're right. I thought it was backwards. I don't know why.
Guys, got a lot to do today. Now there's a couple of ways to go about doing this one. If I look at it this way, if I write out secant squared minus 1, that's 1 plus tangent squared is secant squared.
Right.
That would give me a tangent squared in the numerator, and then I'd still have a secant plus 1, which we don't want. But notice how both the numerator and the denominator have secants already involved with them.
Cancel out.
How?
Secant plus 1.
You play war.
Can't.
What?
Because it's not a factored form. Think of the numerator as x squared minus 1, the denominator is x plus 1. But what could you do to the numerator? Factor it. I can factor, there's one way of doing this is I can factor the numerator. Is secant squared a perfect square?
Yes.
Is 1 a perfect square?
Yes.
Is that a subtraction sign?
Yes.
Okay. So in theory I could do this. Secant minus 1,
That's what I
secant
said.
plus 1
That's what I said.
over secant plus 1.
That's what I meant to say.
What happens?
Plus 1.
Plus 1.
What's secant minus 1 plus 1? Go to the next problem.
You could do the same thing if you multiply the whole fraction by secant minus 1.
Yes, sir.
What's it?
Yep, it would simplify themselves through. It would work itself out because you get things that will drop through.
If you just cancel out this, just do how he wanted to, it
That's-
wasn't the same.
It's the wrong right. It's the wrong mistake. It does algebraically. It's not correct. Algebraically, you cannot do x squared minus 1 over x plus 1 and say that's simplified over addition, and that's bad.
We're killing puppies. More and more like kittens.
It's something like that.
It's killing my
Baby
some other
monkeys.
adorable Mr. Murphy.
Yo.
What do you say? Oh, actually, never mind.
As you get to the verify, it's telling you what your answer has to be in the end. So when I'm looking at this, one of the things that I notice is that I have a sine squared times the quantity cosecant squared plus secant squared. Knowing that sine squared and cosecant squared, they're inverses of one another, aren't they?
Right.
What happens when you multiply two things together that are reciprocals? You're going to get 1. So I'm thinking about that in the back of my mind because if I distribute this through, I get sine squared times cosecant squared plus sine squared secant squared. Now I know that cosecant squared is the reciprocal of sine. So I can write that as sine squared over sine squared. And what's secant reciprocal of? Cosine. So I can say that this is sine squared over cosine squared. What's sine squared divided by sine squared? 1. What's sine squared over cosine squared? And what does that equal?
I thought cosecant squared plus secant squared is 1.
Sine squared times cosecant squared. That's reciprocal property. Anything times its reciprocal is always 1. And the reason that it works is because I rewrote it out.
Is that the one where you put the check mark in the slide?
Yes. Okay.
Good, so you get all your points.
Or not. Right. Verify.
Oh, verify. Oh.
You're not solving anything here.
Okay.
You don't know how to do that yet. Okay. JC.
How did you get for the sine squared secant squared? How did you get sine over cosine?
Secant squared is 1 over cosine squared. So then I just rewrote that here. Sine times 1 over cosine is sine over cosine. Okay, that's all it was. I just rewrote it like that.
How did you get from sin squared over sin squared?
There is no sin here. This is not a 9 Inch Nails song.
To 1 plus
How do you get from what?
How do you get from the fractions to 1 plus
What's sine squared divided by sine squared? What's sine squared over cosine squared? It's not a 9-inch nail sum. It's not 9-inch. No. It's not the pretty hate machine. Track number 5.
We're in the 20th century.
Nobody knows who they are anyway.
What?
Just as far as the properties go,
Yes.
with secant squared, is this something that one
Yeah, it's the same. Yeah, it's the same thing. That's why it works. Okay. 36. This is a great example of one of the properties that you will see very, very often. So we have secant squared plus cosecant squared, and all of a sudden it equals secant squared times cosecant squared.
And that disobeys every rule of math I've ever learned.
So when you see things that start as multiply, excuse me, as you see things that start, as you see things that start as addition, but then they wind up in multiplication, what had to have happened at some point in time, especially when you see reciprocal properties, is that there had to have been some sort of a common denominator. This is the example that you want to rewrite your starting points in terms of sines and cosines. Secant squared is 1 over what? So I have 1 over cosine squared plus 1 over sine squared. What's going to be the common denominator between cosine squared and sine squared? Cosine squared, sine squared. We'll put them together. Fraction on the left needs a fraction on the right needs a the other one. Very good. What's sine squared plus cosine squared?
1.
Same thing.
1 over cosine squared is secant squared. 1 over sine squared is
Check mark. Hey, you forgot the check.
Okay, hold up. I forgot the property that allows you to do the thing that you just did by putting the sines and the cosines on top with an addition.
it's called adding fractions. Common denominator.
Now look that back up.
Guys, it'd be a lot easier if you guys were just quiet. What's the common denominator?
6.
Fraction on the right needs a
2.
fraction on the right needs a
3.
It doesn't change.
Okay. All right. Thank
Bella,
you.
what's that?
I'm just trying to figure out.
Common denominator. Yes, sir.
Sine squared plus cosine squared equal to 1. Like it's like,
squared plus b squared.
okay, wow.
Secant minus cosine over tangent squared. Again, there are a bunch of different ways of going about this problem. One of the ways that I would do it is because I noticed that I have reciprocal properties in the numerator, and then I have tangent squared in the denominator. I know that I can rewrite tangent squared in terms of sines and cosines. I know I can do that. I can also, since I have subtraction in the numerator, I can create a common denominator and write it as one giant fraction. So automatically, I'm going to rewrite secant as cosine. Secant is 1 over cosine. It's the reciprocal. So if I'm looking at just the numerator here, I have 1 over cosine minus cosine over 1. What's the common denominator? Cosine. Fraction on the left means nothing. It has it. Fraction on the right means the cosine. So this becomes 1 minus cosine squared. What's 1 minus cosine squared? Sine squared. Okay? Now, tangent squared in terms of sine. Yes, sir?
Where does the squared come from? It needs the other cosine.
It needs the other cosine. Remember, this is just adding fractions. This is 1 over 1/2 minus 2 over 1. The common denominator is 2. Fraction on the right has 1. Fraction on the left needs 1. Same thing. Fractions?
Where we did the adding and subtracting.
Yeah. It's polynomial adding subtraction. It's the same. Yeah, same thing, but just says tangent instead of x minus 12. Tangent squared, sir.
I just split the fraction. You did secant and then you flipped it. Is that?
It's a reciprocal.
Is that it?
Yeah.
What was that tangent split? Is that what you just? Oh.
Yeah.
Just making sure I'm still on track. I thought I got lost for a second.
Numerator, I have everything written right now in terms of sines and cosines. Do the same with the denominator. Tangent squared in terms of sines and cosines would be what? Sine squared, cosine squared. So as of right now, I have that complex fraction. Rewrite it horizontally. Sine squared over cosine divided by sine squared over red color. What do you do when you divide fractions? So we're going to multiply by the reciprocal. What simplifies? Sine squareds go, and 1 cosine goes, and you get.
Oh my gosh. That was funny.
A lot of times it's just rewriting in terms of sines and cosines will get you into this. Yeah.
So these can be used if they're just square?
Mr. Murphy, I kind of have a question. So, 1 plus tangent, is that still equal to like?
No.
It's not?
Nope.
Okay.
Pythagorean identity has to be squared.
All right, because I wasn't sure, because if you like square root that whole equation, then it just works out.
This problem is basically the exact same thing. You're going to want to rewrite things in terms of sines and cosines and get common denominators twice. You're going to do that with the secant cosecant, and you're going to do that with the 1 plus tangent. So you split this out into 2 fractions. Secant is the reciprocal of what? Cosine. Cosecant is the reciprocal of sine. So I have 1 over cosine plus 1 over sine. Common denominator will be cosine sine. Numerator, that will be sine plus cosine. Or yeah, either one. Okay. I can't do anything else with it because it's not squared. Right? But I have everything written in terms of sines and cosines. I do the exact same thing with the denominator. Tangent is what over what? Sine over cosine. So I have 1 over 1 plus sine over cosine. What's going to be the common denominator? Cosine. What's the numerator? Very good. Which means I have a complex fraction again. Sine plus cosine over cosine times sine. Is it okay if I just flip it right away? Divide by the bottom, so I'm going to flip it. I'm going to multiply it by cosine over cosine plus sine. What drops?
Everything except the sign.
Is that sine wearing a flotation device?
No.
Someone said it. Yeah, cosecant.
Oh man, everything makes sense now. I was so confused earlier.
How does any of this stuff help you in life? It's problem solving.
No, just like
Solve
what
problems.
he's explained over the last.
Go through a list of things to solve a problem. Take a bunch of information you have to solve a problem. Casey,
Is there any way to solve it and use the 1 plus tangent? Oh wait, never mind.
JC, there's another way to do this. There is another way to solve this one out. You could take secant, secant plus cosecant over 1 plus tangent and multiply it by a conjugate. You could do that, but it's nasty. It's just not, it's not fun. Show you another one. It's 37. We'll probably have time to do about 5 or 6 more of these things, and I'll have you guys finish out a few of these on here then. 37. Cosine of the fourth minus sine of the fourth, we want it to equal cosine squared minus sine squared. Well, is the first term perfect square?
Yes. Yeah.
Is the last term perfect square?
Yes.
Is that a subtraction symbol?
Yes.
What are your two terms?
Cosine squared plus sine squared.
Cross what out? No! We're making the left look like the right. Yes, sir.
And then cosine squared plus sine squared equals 1.
Very good.
Alright, I think I got this now. I was panicking earlier, but
One step. What's cosine squared plus sine squared? 1. It simplifies to 1.
yeah, this is like a
Divided by cosine minus.
It doesn't like, we have to set it to like a collaboration.
What's cosine squared plus sine squared?
It's
1.
But if you were
And
to
what's
divide
1 times?
each side
No.
by-
You're making the left look like the right. You're not dividing out. If you start doing that, things start dropping out. You don't want that. Okay. Yes, sir.
Are you done? Because there's no check marks.
Oh, shut.
Mr. Murphy,
Yes, sir.
is this like the combination of everything that we've learned during the entire year, like just like coming together?
Yeah, a lot of it starts going like that. Yes.
Alright, is that like what math is going to be like from now on?
A lot, yeah.
All
38.
right, sweet. Makes me happy.
Cosine squared times tangent squared plus sine squared times tangent squared plus 1 equals secant squared.
All done.
Check mark, smiley face. Okay. Now, third hour, I went through this one and just I saw that we had sines and tangents and all that other stuff, and I thought, hey, let's rewrite everything in terms of sines and cosines. Well, we got about 7 steps in and realized it wasn't going anywhere. So I said, you know what, I bet you I screwed up somewhere along the way, or I wrote something down wrong. Let's do the next problem. And I expect that you guys are going to screw up. You've done this once. You're human, okay? So what happened was that if you do get to the part where you just kind of like, go to the next problem, okay? Okay? Seriously. Try it again. Because when I went back, guys, when I went back to it about 10 minutes later, I stopped and I looked. I said, hey, wait a second. What do those two have in common?
Tangent squared.
Tangent squared.
Tangent squared.
No.
What's cosine squared plus sine squared? What's tangent squared times 1?
So we have to do group factoring now too. This is awesome. This is just great.
Like die.
Again, it wound up being 2 steps. And it was one of those things that was hidden within the problem. You had 3 terms, and hidden within it was there was both the first 2 terms shared its tangent. So we factored it out and rewrote it through. Okay? So a lot of times it's the idea that you seem to overlook an obvious solution, and I did, and it happens. Okay? A lot of these shouldn't be any more than 3 steps. Some are a little bit more, but not that often.
4, 5, 6, maybe 7 steps.
Mr. Murphy?
Yo!
That one, the one, she's just disregarded.
Yeah, because it's tangent times 1. That's all. Was there more?
What number is this?
46.
Is that 1 plus cosine?
It is. Simplify this one out. So, if I'm going to add fractions, what do you have to have? Common denominator. My common denominator here is going to be sine times 1 plus cosine. Fraction on the right, or excuse me, fraction on the left needs a, so it becomes sine squared. Fraction on the right needs a 1 plus sine, which means you have to do the following. Excuse me, cosine. You have to FOIL it out. Don't kill the puppy. You get 1 plus 2 cosine plus cosine squared.
Okay. Would calling that 1 plus cosine squared be killing puppies?
The quantity 1 plus cosine squared is fine. Because that's what it is. It's the quantity 1 plus cosine.
Okay, so then does
But then you have to FOIL it out anyway to continue.
okay.
It won't get you anywhere.
All right, it doesn't drop out.
Nope.
Oh, okay.
It won't drop because you have the addition in the numerator.
Oh,
You won't
yeah,
drop
it's
until
got-
you
it's
won't
got a
drop
plus.
until you have
You're
everything
right,
in
right.
terms of terms. If that makes any sense. So now in your numerator, you have some stuff you can simplify. What's sine squared plus cosine squared? 1. So
Oh my god.
I have 1 plus 1 plus 2 cosine, which is
2 plus 2.
very good. I'm not rewriting the denominator for right now because it's the same thing. Numerator. What do they have in common? Factor it out. Now that I'm at a point where I have terms above one another, that's where my terms are allowed to be able to simplify out. I get 2 over sine, which is 2 cosecant. You can't simplify until they become terms.
He's gonna fight you. He's gonna get thrown out.
I got it open up.
What number is this?
30. Excuse me. This was just on my recent pre-calc test.
Like the one you took or the one your students?
Take a picture. Wait, can you give us a second to try to figure out by ourselves?
Sure, go for it. Yeah, absolutely.
Awesome.
Verify.
Oh man, it's coming up. Verify.
Oh, did you ever find your potato?
No, there's a video on it. Go show them.
Yeah.
No, I'm busy. You guys are busy doing
Wait,
math.
wait.
Show me later.
It's like 30 seconds.
Would there ever be like a no solution?
No, not with these. Good question.
So if there's never a no solution, can you just say that it's verified?
No, you can't just skip and say because it is so.
Wait, what if you got the exact inverses or verified solutions?
I don't know. I'd have, it could happen, I guess. I don't know.
Like, let's say you start off with like a sine over 1 or something, and then you end up with 1 over sine.
I don't know. So how do you go from cosine squared minus sine squared to equal 1 minus 2 sine squared?
Wait, Mike, you have to, you said we had to be on the left.
It's always easier. All right, technically you're not wrong, but in here I want you guys to go left to right. More often than not, they should go left to right. Okay.
Yeah, add sine.
And sine each side.
No.
No, you change the cosine to the 1 minus sine squared.
I changed the 1 minus 2 sine squared to 2 cosine squared.
One step.
Oh, I see.
All right.
Because what's cosine squared? 1 minus sine squared. We are not. No. We're not. You don't work back and forth on both sides of the equal. We don't do that in here. We go left to right. Make the left look like the right.
That's amazing.
What you're doing by bringing, if you add the 2 sine over, you're going to get.
Sad face.
It's another one of them showing the Pythagorean identities work, but in this case, I want you to go show the left equals the right. You're not mixing them together to verify them. Okay. Yes, sir.
So, when you're doing these verify problems, the main goal is simply to, like, you can
Make
go
the
back
left.
and forth. Like, you can work backwards. Like it's not trying to simplify, like you can unsimplify.
You want to make the left look like the right.
All right.
Oh, right.
On that same sheet there, I think I have given you guys ample examples of all the different styles that are left over. Be resourceful going back and forth with them. On some of the more complex ones, what I will do tomorrow morning when I get here, I will put some of the solutions up on the window so you can check them.
All right. Homework.
This is fun to watch when people walk by. They see all this nasty stuff on the
Wait, is
windows.
there a solution to the problems that we're doing now, or solution to something?
I'll throw some of the solutions up there on the ones that I know are more complicated than others.
Okay.
All right? Yes, ma'am.
So for verifying, do you want me to
Yes, ma'am. Keep going until you can stop. Yeah.